Hello everyone, welcome to Webutorial.com. We bring you another lecture in geometry and I call it the art of construction. And at the end of this, I'm pretty sure that you are going to say these lines as well. Okay? In this class as well, I'll take 3 questions. One of them will be this. This is my question number 2. Before I go to this, I'll solve one more question and then I'll wrap it up with the third question. In all these questions, we will see some interesting constructions to be made and how can we derive some results. Okay, so let us go to our first question. This is our first question. In this question, we have been given 2 intersecting circles and the points of intersections are P and Q. Okay, it is also given that 2 lines AB and CD are drawn parallel to each other through the points of intersection P and Q. Now it is given that the length of AB is 5 cm, AC is 3 cm, EF are the centers of the circle. We have to find the perimeter of the quadrilateral ABDC. Okay, to solve this problem, the method is to draw perpendiculars from the centers on the opposite sides. So suppose I drop this perpendicular over here and on this side as well. So these 2 lines are perpendicular over here and you do the same thing over here. Okay, let us call these points as J, K, L, M. Okay, so now look at this quadrilateral JKLM. In JKLM, clearly it can be seen that it is a rectangle because these 2 lines are parallel to each other, these lines are parallel to each other and one angle is 90 degree. Okay, in fact all the angles are 90 degree, but for rectangle we need a parallelogram and 2 angles as 90 degree. If JKLM is a rectangle, we can write that JK will be equal to ML. Now JK can be written as JP plus PK, ML can be written as MQ plus QL. That implies 2JP plus 2PK equal to 2MQ plus 2QL. If this is the thing, you can see that this is a perpendicular over here, therefore these 2 sides will be equal. Okay, because at J, AP chord will be bisected by this perpendicular from the center. Therefore 2JP is AP, 2PK becomes PB, on this side it becomes CQ and this becomes QD. That means AB is same as CD as well. Okay, now we have in a quadrilateral AB parallel to CD and AB equal to CD. This means AB DC is parallelogram. Thus perimeter is simple, it is just 16. So this is easy, right? Alright, now we have seen this problem. Let us take a look at a different problem which uses the concept of this problem itself. The construction over here was pretty simple. In the next problem, the construction will be slightly different and a bit complicated. Let us look at that next problem. So this is our next question. In this question, we will try to find the length of AB when the length of CD is known. It is also given that in these 2 intersecting circles, the lines AB and CD, they make same angles over here with PQ. Alright, so in this question, we'll try to find the value of AB. Alright, the first thing that we have to do is to do a construction, and the construction is that we draw a line CD, C dash D dash, which is parallel over here. Okay, so something like this. We will draw a line going through Q, which is parallel to CD. Let us call this, let's say PQ is taken, so JK. Alright, so we have drawn this line parallel to that. So JK is parallel to CD, and from previous problem we know JK will also be equal to CD. Okay, so both these lengths are 10 centimeters. Alright, now let us try to see what is happening over here in something like A, P, Q and J. Okay, so this thing we are trying to examine. Let me take a different color. Yeah, this might be better. Oh god, I get the idea, right? I'm trying to examine this, and suppose this was extended and it met somewhere. Okay, we need to find out where it meets. All right, that will help us in understanding the solution. Anyways, if you look over here, we know that the line joining the centers bisects this common chord at 90 degree. All right, so this point is the midpoint. Therefore, if we call this midpoint as some value, say R, if the midpoint is R, then we have PR equal to QR. Okay, so P and Q are 2 points which is placed symmetric about this line R. But also what we can see is that this PQ is transversal for the parallel lines CD and JK. Therefore, this angle will be same as this angle, and as per given, these two angles are same, so these two angles are same as well. Therefore, what we can observe that these two things will meet over here itself, which is the common bisector. We know that from theorem in geometry, if you have a line, okay, so the locus of the point which is at equidistant lies on the perpendicular bisector of the line. Okay, so same thing is happening over here also. What we have in this problem is something like this. This point is P, this point is Q, this is R. Somewhere over here we have got E, and this will be produced. Right now we have only this much of the quadrilateral or this much of the triangle. If you extend, obviously these two are going to meet. What we can see that this line and this line will be same. If we use the same logic that this angle over here, okay, no, not this angle, this entire angle over here will be same as this entire angle over here, and therefore this will become equal, and that way we can prove that not just AP is same as JQ, this we had proved earlier, but also PB is same as QK. Yeah, QK. So if you add this, you will get that after adding these two, AP plus PB gives you AB, and this will be JK. This is equal to 10 centimeter as well. Alright. In this question, the construction to be drawn was that we have to draw a line parallel so that we can obtain some kind of a parallelogram and then examine this line with this line. Alright. Now let us take a look at the next problem. So this is our third problem. So let us try to understand this problem. First thing that is given to us is that triangle APC is right angled at P. PM is drawn perpendicular to AC. The lengths of AP and PC are known. We have to find this missing length. Now this is a very interesting question. Alright, so I'll explain to you in a very interesting approach as well. First thing that you should see over here is that we can calculate the value of AC. AC will be root under 20 square plus 15 square. This is 25. However, we discourage the use of this method. Okay, the idea is that you see that AC is hypotenuse, so list down other sides in triplet form, and this is X. Now 5 and 20 have a HCF of 5, so you leave 3, 4, and obviously next triplet is 5. So we had left of 5, you multiply, you will get 25 directly. Alright, in a right angle triangle like this, if you if you drop a perpendicular, alright, what happens is that both this and this are similar to the bigger triangle and to themselves as well. Anyways, what will happen over here is that if this length is 20, this length is 15, this entire length is 25, this thing will be divided as this will be 12, one of them will be 16, one of them will be 9. You can do this by using all your algebra, okay, but this is the way it works. Alright, In short, you can see over here also 20 becomes the hypotenuse for this right angle triangle. So you need what? If you have a 3 4 5 triangle, these angles correspond to 3 4 5 triangle. Therefore again over here also 20 will correspond to 16 and 12, and similarly this 15 of hypotenuse will correspond to 9 and 12. So 12 becomes the common side, 16 and 9 come over here and here. Alright, so far so good. Let me clean this area up a little and we will just label all the sides that we have found out. Okay, so this length is 16, this length is 9. Okay, now take a look over here. This is not needed, this is not. What we do in this construction is that we extend this line AC to a point F, okay, such that BC and CF are equal. Now let us join this. This is the thing to join. Okay, we have joined it. Also we can join PB. Yeah, join PB as well. That will be helpful. Let us now try to solve this problem. Over here, if you assume this angle to be alpha, then this angle will also be alpha because BC is same as CF. If these two angles are alpha, what will be the value of this angle? This angle is 2 alpha. If this angle is 2 alpha, then this entire angle will also be equal to 2 alpha because angle in the same chord. Now take a look at these two places. We have two angles, one of them is at P, one of them is at F. The angle present at P is twice the angle present at F, and both of them are on same line segment AB. Therefore, we can envision a circle that passes through AB and F with center P. It will be a pretty big circle, something like this. You get the idea, right? This is how the circle is going to be. And the center of the circle is at P. If you see like this, now our problem is almost done. If this is going to happen, what we can see is that in this bigger circle, P is the center and AF is a chord. AF is chord. PM is perpendicular to AF, therefore AM will be equal to MF. Alright, if AM is same as MF, then we have AM equal to MC plus CF, which is MC plus BC. If this thing is happening, then we know the value of AM over here as 16, MC is 9, so BC value will be 16 minus 9 equal to 7. So these were our three problems. So this brings an end to this lecture. I would like to tell you about the offer that Webutorial.com brings to you. We are going to conduct a couple of crash courses. One of them will be on numbers, one of them will be on geometry, and they will address CAT questions and CAT kind of questions in the workshop. This will be a only 3-hour workshop for them, and 99 is the price for each course. The date is our Independence Day. For any queries, please drop a mail at admin@webutorial.com. Thanks a lot for being with me. I hope you enjoyed the video.